Okay, lesson 2.1 is linear and quadratic functions and modeling. There is a decent amount of this stuff that you're familiar with. We've worked with linear, we've done that in Algebra 1, Algebra 2, and now Pre-Calc. Quadratic you worked with in Algebra 1, Algebra 2, and Pre-Calc. So you're going to see some familiar stuff, and we'll, mix in a little bit of new stuff as we go. Let's go back to Algebra 1 for a moment, though. Polynomial functions. Maybe even, honestly, pre-algebra. I feel like I talked about polynomial functions when I taught middle school math, so maybe even pre-algebra. Any function that is a sum or difference of x values having whole number powers and real number coefficients. This is what we're talking about when we talk about a polynomial function. So a good, solid definition you need to know. Notice it says it's a sum or difference of x values, so there can be terms added or subtracted together. They can only have whole number powers. So when we talk about whole number powers, keep in mind, what is a whole number? Whole numbers have to be what? What did you say, Miles? Above zero. And so above zero, so no negatives. And they have to be whole numbers, right? What you guys think of as whole numbers. So no fractions, no decimals. So if it's a part of a polynomial, positive whole number powers and real number coefficients. So no imaginary numbers. Okay, so that's definition of a polynomial. Now we've got kind of a chart here that has some names. Most of these you're familiar with, although the zero function, I don't know, we've talked about that as a name before. It's not one we use much, but the zero function is f of x equals 0. Now keep in mind, f of x is another name for what? Y, right? So in all of these, you can think about it being y equals. So the zero function is just y equals 0. When we talk about degree, the degree of that is undefined, and the leading coefficient, we'll normally talk about the number in front of x, which in this case is just 0. Okay, so that's kind of a special case. The constant function, f of x equals a or y equals a, where a cannot equal 0, where a is just some number. So thus it is the constant function. The degree, well, think about it. There's no x, so it's x to the power of 0. So the degree is 0, and the leading coefficient is the a right there. What you're probably more familiar with, the linear function. It's not exactly this, but a lot of times when we talk about linear, we think y equals mx plus b. This is y equals ax plus b. Degree. Is degree coming back to you? Where's the degree come from? The degree comes from the highest power. And so if this is ax plus b, that is x to the power of 1. So it's a degree of 1, leading coefficient again of a. So in other words, the number multiplying in front of the variable there. Quadratic function. I'm familiar with quadratic. Quadratic means my highest power is 2. So it's a degree of 2, leading coefficient of a, so that ax squared plus bx plus c. Cubic means a high power of 3. And so ax cubed plus bx squared plus cx plus d, degree is 3, leading coefficient again is a. So you've seen that in various forms. I know you saw it in Algebra 2, more or less Algebra 1. So just a few basic examples to go with this. The questions be, which of the following are polynomials? So in other words, are these polynomials? Are they not polynomials? In other words, do they meet that definition of a polynomial? And then for those that are, we're going to state the degree, leading coefficient, and then if they are not a polynomial, we're going to state why not. So A, f of x equals 4x cubed minus 5x minus 1/2. First of all, we've got to think, do we think that this is a polynomial? Does it meet that definition of a function that is a sum or difference of x values having whole number powers and real number coefficients. Jacob's giving me a thumbs up back there. Meets the definition, doesn't it? It's adding, subtracting terms, all real numbers, whole number powers. So yes, it is a polynomial. Well, so then if it is, we need to talk about the degree and the leading coefficient. Degree. What are your thoughts on the degree? 3. My highest power is 4x to the third. So this is a degree 3. If you had to give a word, so I was just looking at my notes. If we had to give a word, we could say that this is a cubic, right? Depending on what, I can't remember. I'll have to look. I don't remember if homework wants numbers or names, but it's degree 3 or it's a cubic. What about leading coefficient? 4. So the coefficient of that highest power leaves me a leading coefficient of 4. Okay, B. G of x equals 6x to the negative 4th plus 7. Is it a polynomial? Why not?
Because the power is negative.
Yeah. My original direction or original definition said whole number powers. Whole number powers start at 0. Okay, so 0, 1, 2, 3, 4, 5, 6. They don't include negatives. So no, this one is not a polynomial. And the reason being because there is a power that is not a whole number. So my explanation is going to be power is not a whole number. If you want, you could say power is a negative. Okay, C when you're ready. H of x equals the square root of 9x to the 4th plus 16x squared. And again, the first question is, is that a polynomial?
Yes.
I got a thumbs up, I got a yes. What about that square root there? Okay. So the attempted rationale here is that, okay, I can do the square root of 9x to the 4th, that's 3x squared, the square root of 16x squared, 4x. So then I have 3x squared plus 4x. Now the catch, though, can you take the square root of a sum or difference? If this was 9x to the 4th times 16x squared, yes, we could take that square root. But because it's a sum, we can't take that square root. That square root has to stay there. Does that change your mind about whether or not it's a polynomial?
Maybe no, because it isn't a real number.
It is a real number. It's not imaginary. That's not the catch.
Because you can't square root because of it.
Yeah. What power is a square root? If I rewrite this as 9x to the 4th plus 16x squared raised to some power, Do you remember what power a square root is? What's my index? A square root has an invisible index of 2. Not -2. That makes this a fraction. What? 1/2. So that has a power of 1/2. And that gives me a fractional power, a rational power. But is it a whole number power? It is not. So because I agree. If we could take that square root, I would be fully behind you and say, yeah, it's a polynomial because I can simplify this. But I can't take that square root. And so, no, this is not a polynomial. When you see those square roots, you're probably going to need to lean towards saying no. Okay, what's my reason? Well, officially it's the same reason as last time. Power is not a whole number. Now, the short of it, if you'd rather think this way, it's not a polynomial because we had a square root. Okay. Get what you need there. Then one more. D k of x equals 15x minus 2x to the 4th. And again, the primary question is k of x a polynomial? You don't like how they wrote it. Could you rewrite it if that would make you happier? I mean, there is a point with saying she doesn't like how she wrote it. But aside from the fact you don't like the order they put it in, is it a polynomial? Yes. Now, if it's a polynomial, what questions did we have to ask? We had to answer degree and leading coefficient. What is the degree? What was that? 4. Thus, you don't like how it's written, right? If you prefer, you could come back and say, okay, this is really negative 2x to the 4th plus 15x. You could rearrange that if that would make your life a little happier there. But yes, degree 4. If my degree is 4, what about my leading coefficient? -2, because it's the coefficient of that highest power there. So don't fall for the, oh, leading coefficient is 15 because that came first. Okay, questions there? Nothing too crazy hard this Monday morning after break. Making you think, but not too crazy hard. Okay, so that was a little bit of definitions about polynomials. Let's scroll down here and talk about linear functions. Let me get rid of all of that. There we go. Okay, so linear function. You guys are familiar with linear functions. When we talk linear, what do you know about linear? It's a line, right? It's a straight line. What else are you going to say?
Are they never mind. I was going to say they're linear functions, and I was like, wait. Never mind.
Well, my other question is, the graph is a straight line. What's the power? or the degree? If it's a linear function, it's going to be a degree of 1, right? Okay, so degree of 1, polynomial of degree 1 with leading coefficient. Notice it says equal to the slope, because when we think linear, we think y equals mx plus b. And notice that is right here, f of x equals ax plus b, same as thinking y equals mx plus b. Okay? While we're talking here, the constant function. Okay? So the constant function that was mentioned up above, okay, wait a minute, something doesn't make sense here. Okay. So the constant function that we mentioned up above, that's y equals a number, is the graph of a horizontal line. Okay, so constant function kind of goes in with linear functions. However, vertical lines, remember vertical lines are exception. They are not functions because a vertical line would not pass the what? This is where it doesn't make sense. A vertical line would not pass the vertical line test, right? Because you draw a vertical line and it lines up with the vertical line. Okay, that's what that was supposed to say. Just a little mistake there. Okay, linear functions, what we're talking about, are the slant lines. So they're not the horizontal lines, the special case of the constant function. When we talk linear functions, we're talking the slants. Okay, we're talking some slope other than 0. Now, look at this example. It may look different, but you know how to do it. That information is in your brain. You just have to get it there. Okay. Example, ask us to write an equation for the linear function f of x such that f of negative 1 equals 2 and f of 3 equals negative 2. Any thoughts? And I know part of what you might be struggling with is the form of how they gave this information.
Wouldn't it just be 2 points, and then one would be -1, 2, and the other one would be 3, -2?
Yeah. The weirdness about what they gave here, and I shouldn't use the form, I shouldn't say weirdness, but, you know, the difference, you're used to, if you have to write the equation of a line, you're given 2 ordered pairs, right? They didn't give me 2 ordered pairs in that exact form, but they said f of negative 1 equals 2. Well, keep in mind, negative 1 is an x value, the input is an x value, and then that makes 2 the y value. So this is the ordered pair, negative 1, 2. F of 3 equals negative 2, so x is 3, y is negative 2. So that gives you the ordered pair, 3, negative 2. Does that look a little bit better if I give them to you as ordered pairs? Your brain might not be quite there, but it should be closer. If it asks us to write a linear function, what's the form you're going to be thinking about? Y equals mx plus b, hopefully. So I'm going to write this over here. We have negative 1, 2. We have 3, negative 2. What do we do first? Find the slope. M equals, how do we find slope? No? What do you remember?
It's either the y is y2 over -1
Uh-huh.
x2.
Yep, y's over the x's. So you're subtracting the y's on top, x's on bottom. So a lot of times we say y2 minus y1 over x2 minus x1. Now, and keep in mind though, technically you can use either set as your second pair, right? So you can subtract these in either order as long as when you get to the denominator, you're consistent with what you did, right? So what did you guys want to do in the numerator here? Did you do negative 2 minus 2 or 2 minus negative 2? You do negative 2 minus 2. If I do negative 2 minus 2, what must I do on bottom? 3 minus negative 1. Negative 2 minus 2, 3 minus negative 1, negative 4 over 4, which simplifies to be negative 1. So we know that our slope is negative 1. We have two different options of how we could go from here. And I don't know what your thoughts are about this. How do we go about writing that line? What do you guys do?
Point slope.
Huh?
Point slope.
Do you guys use point slope? Do you remember point slope? One option, and what you might have learned back in Algebra 1, so before you had me, is you might have used y equals mx plus b, and I'm still okay with that. Where you can pick, you have to use this slope, and what do we have to do? We have to pick one of our ordered pairs, right? Does it matter which ordered pair we pick? No. Pick one of your ordered pairs. Which ordered pair do you guys want to use when it comes time? We have a negative either way, don't we? If I had to guess, you guys are going to pick this one. Okay, so we're going to use that slope and one of the ordered pairs. If you want, you can plug them right in here, can't you? You can plug in x, y, and m and use that to find your b. And then you can write your equation. Or, in Algebra 2, I suggested, and maybe you saw this in Algebra 1 as well, but I suggested using point slope to get there. Y minus y1 equals m times x minus x1. And both ways will get you there in the end. So y minus, my y coordinate is 2, equals m, so slope of negative 1, times x minus my x coordinate of negative 1. And then you just have to solve this for y, right? So I'm going to say y minus 2 equals, let's see, minus a negative is really plus, and then if I distribute that negative 1, it becomes negative 1x minus 1. If it's y minus 2, I can add 2. So I end up with y equals negative x plus 1. Did anyone try and go the way and find b instead? Either way works. I don't have a preference as long as it just comes down to you have to have a way that you have confidence in that you can find. Okay, so they said write an equation. So we could say y equals negative x plus 1. It did say for the linear function f of x. So officially I could say f of x equals negative x plus 1. Again, I'm fine with y equals negative x plus 1. Officially, as I said, linear function for f of x. So really that y should be replaced with f of x. Okay. That's technically an Algebra 1 skill that we reviewed in Algebra 2. Did it come back to you a little bit today? Okay. Okay. Down at the bottom here, and where you have some examples on the next page. Average rate of change is a phrase you often hear in math. And you'll notice here it says the slope of a linear function. So you're familiar with the word slope, right? We just talked about the word slope. But the slope of a linear function, m equals y2 minus y1 over x2 minus x1, characterizes something called the function's rate of change. When we talk about a line, the slope talks about rate of change. At what rate is that line going up or going down? At what rate is that line changing? A linear function's rate of change, so the m value is constant, because a linear function, a line, has one rate of change. If the graph was curving, that's a whole nother story, but we'll talk about that later. All functions have rate of change based on different values of x. There's an average rate of change for a function given an interval. So when we talk about a line, one rate of change because that line is constantly changing the same. When we talk about, say, a parabola, the slope around the parabola is not always the same, is it? It changes based on where you're at on the parabola. And so that's what we're going to talk about here, is that we can talk about average rate of change given an interval. So if we're asked, okay, what is the rate of change from 0 to 1? Or from 0 to 5? Then we can see, okay, what is the average slope on that section? Okay, not that I should be using the word slope, but it's the average rate of change. So if you would, flip to the next page. Let's look at a few examples. Okay. Average rate of change of a function y equals f of x from x equals a, between x equals a to x equals b, where a cannot equal b, is given as this formula here. F of b minus f of a over b minus a. And that is based on an interval from a to b. That is our average rate of change. Now you'll notice a cannot equal b, because if a and b are the same values, then that means there is no interval. You know, we can't find the average rate of change from 2 to 2. It doesn't work. Okay, so average rate of change from a to b, so notice a and b are my x values. And we use f of b minus f of a over b minus a. If you think about this, this equation is very much like slope. B minus a are my x values. F of b minus f of a are going to be my y values. So let's look at example A. Compute the average rate of change for f of x equals x squared from x equals negative 2 to 0. So just that one portion of the graph. So f of x equals x squared is our function. What is x equals negative 2 and x equals 0? Those are what? Yeah, those are x values. And so in this, in terms of the formula, they're essentially going to be my a and b values. Officially, I'm going to say a is negative 2 and b is 0. Technically, the way it shows, a is bigger than, or excuse me, a is smaller than b, so b is your bigger value. In reality, it's not going to really matter. Okay. Now, I know a and b. I also need to know f of a and f of b to do the top of this. So before we get too far into this, let's find f of negative 2 and f of 0. What is f of negative 2? 4, right? Because you take negative 2 and you square it, and negative 2 squared is 4. What is f of 0? 0, right? So we know here that f of 0 is 0. F of negative 2 is 4. That's the information that we found there. So using this formula, using our average rate of change, f of b minus f of a over b minus a. So as we look at that, f of b is going to be, I'm going to write it this way the first time through, f of 0 minus f of a. So f of negative 2. Okay, so f of b minus f of a over b minus a, so that's going to be 0 minus negative 2. Fill in your values if you haven't already. F of 0 we said was 0. Minus f of negative 2 we said was 4. And it's already over 0 minus negative 2. What do we end up with? Negative 4 over 2, which is negative 2. Average rate of change. Basically, we found slope of one section of a parabola. So the average slope, or average rate of change from negative 2 to 0 on this parabola is negative 2. If you think about a parabola, does it make sense that it's negative there? I mean, a parabola looks like this, right? And if this is centered at 0, 0, I guess I really shouldn't be working here because I'm going to need this. If you're going to draw this in, don't draw it in right here in your notes because I'm going to need this section later, okay? But from 0 to negative 2 is right there. Does it make sense that we'd have a negative slope? And it should. Okay? As I said, I'm going to need that for work tomorrow. Not going to get to it today. Okay. Can you go ahead and start B? How about this? Work on B. We'll start off checking B tomorrow as a class. How about we do that? Okay? So we'll start class tomorrow checking B together and then doing C together. And you can try C if you want, but C does have a little twist to it, doesn't it? And then if you want to start the first homework on page 169, you can start it. But we'll talk more tomorrow as well. I'd have to look up and see which questions. I think 78 is your average rate of change problem. So that's the one you could probably do the most of.